Good evening, Cleethorpes. Exploring the Solar System Part 1, Robots on Mars. I'm going to be looking very briefly at Mars and Martians, at landers and rovers, not all of them, but I'll pick a few to use as exemplars. I'll be asking what have they found and asking what is the next step. We as humans have had a fascination with Mars for a long time. When some people think about Martians, they think about War of the Worlds, either the book or the film or the radio broadcast, possibly even the musical. That's for people of a certain age. Perhaps youngsters, if you talk about The Martian, they won't think of War of the Worlds, they'll think more of Matt Damon sitting there looking rather lonely. But we should just remind ourselves how amazing it is that we can do this at all. 100,000 years ago, humans, or at least some humans, were still living in caves. But now it's possible for us to build machines, put them on top of a rocket, send them to another planet, land that machine, and have those machines roam around and send back images like this. High-resolution photos and videos of the Martian surface. It looks rather arid, rather dry, but there are signs that water has flowed. There are signs of dried up lakes, dried up riverbeds. If water has flowed on Mars in the past, is it possible that life developed in the past? Is the water still there, perhaps below the surface? If it is, there's even the possibility that life exists under the surface. And that is probably where we'll be thinking of going next. Exploring the surface, exploring the geology, exploring the climate of Mars is one thing, but ultimately we're chasing the water. So I'm not going to talk about all of the landers and rovers that have been on the surface of Mars. I'm going to restrict myself just to thinking about the ones that NASA have sent. There have also been Chinese landers and rovers. But let's just have a look at some that NASA have sent over the years. It started in the 70s with the Viking lander. Since then, there have been a number of landers and rovers. I'll be mentioning Spirit and Opportunity a little later. There have been others, including the larger rover Curiosity in 2012 and 2020 Perseverance, a rover very similar to Curiosity. Opportunity, sometimes called Oppie, and Perseverance, sometimes called Percy. Given that this is only a half-hour talk, I haven't got time to explore all of these missions, so I'm just going to say something about the ones that I've highlighted there in red. My memories of Mars start with Viking in 1976. No, we didn't send Carl Sagan to Mars. This is him standing next to a mock-up of the Viking lander in the desert on Earth, just to give you an idea of scale. You can see that the lander was about the size of a car, roughly speaking. But I remember in the 70s, I remember the mission, and as much as anything, I remember the first colour images coming back from the surface of Mars. And I thought that was absolutely amazing. Yes, it's incredible to see astronauts bouncing around on the surface of the moon, but I thought a few years later, seeing the surface of another planet like Mars, I thought again that was an amazing technical achievement. If we think about how we get to Mars, well, it doesn't need a very large rocket. A relatively small Atlas rocket shown in the top left is enough, much smaller than the rather mighty Saturn V that took astronauts to the moon. But Mars is of course a lot further away than the moon, and yet you can get there with a much smaller rocket. That's because basically distance doesn't matter. What matters is the mass you are trying to lift off the surface of the Earth and send out into space. Once you're beyond the orbit of the Earth, it doesn't really make that much difference whether you're heading to the Moon or whether you're heading to Mars or even the outer solar system. In the case of the Saturn V, it needed to be a really big rocket because it had to lift over 100 tons into Earth orbit. But to get a rover or a lander to Mars, the lander or the rover might only weigh a few hundred kilograms or perhaps a ton or two, much less than is required to get men or women to the Moon. Let's have a look at how Spirit and Opportunity got there. Let's just pick one of them. Let's say this is Opportunity. When it arrives at Mars, it uses an aerobraking maneuver. The atmosphere is very thin, but with a heat shield, you can go through the atmosphere and bleed off some of your energy. Eventually, you're going slow enough that you can deploy a parachute. It's still supersonic at this point, so the parachute has to be very large because of the thin atmosphere. But eventually it slows down enough that the heat shield can be jettisoned, and in this case the small rover is sitting in that pyramid structure at the end of the tether. But how do you get it onto the surface? It may only weigh half a ton or so, but the easiest way? Airbags. You don't worry about a precision landing. You get reasonably close, you slow yourself down, and then you drop it. You don't have to worry about the exact height at which you drop it. You don't have to worry about whether you're moving sideways or not. You don't have to worry about any Martian winds. You just drop it and let it bounce and bounce and bounce. So of course the rover inside has to be very securely positioned, very securely located such that it could withstand the acceleration and deceleration. Eventually, after 28 bounces or so, it came to a halt, at which point the airbags could be deflated and then it unwraps itself. A very clever self-righting design. So the pyramid unfolds and there's the rover sitting in the center of its now pad. First thing it has to do is to get power, so it has to unfold its solar panels. You can see them unfolding there like a rather dainty butterfly. The solar panels give it power, and in the middle there's a camera on a mast, the white object in the center there. That will then unfurl such that the camera is put into the vertical position, and behind it what looks like a table tennis bat, that's the antenna that allows the rover to communicate with an orbiter and ultimately back to Earth. On top there, stereo cameras allow it to look around and decide, well, it looks like I am the right way up. It can tell Mission Control that it's landed, and Mission Control will then give it the command to actually unfurl itself and go roving. So it lifts itself up, unpacks its wheels, 6 wheels usually, and then it's in a position to come off its landing pad and start roving. Another double check with its stereo cameras on the mast to make sure it knows where it is, and check for any obstacles in front of it. If it looks like there's any obstruction that it would rather not go over, then it will simply navigate around it, usually on instruction from Mission Control. Spirit and Opportunity were designed to have a mission lifetime of hopefully at least 3 months, maybe more. In fact, they lasted significantly more. Spirit lasted for years. Opportunity lasted not for 3 months, but 14 years in total. What is it that ultimately dictates the lifetime of a rover like this, assuming it doesn't get stuck in a gully or something else and any other bad luck befalls it? Power is one of the most important aspects. Here's a selfie taken by the camera looking down on top of the solar panels. You can see those solar panels laid out there with the Martian soil in the background. This is what it looks like when it's reasonably clean. But after a few months, those solar panels can get covered with Martian dust. In fact, if we look at another selfie taken sometime later, There's so much dust on the solar panels, it's essentially the same colour as the Martian surface in the background, and you can hardly see the outline of the rover itself. And of course, if the solar panels get covered in dust, that can limit the efficiency with which they can convert solar energy into power. And power is rather important because of the nature of the temperatures suffered on Mars. If we think of the tilt of Mars and the tilt of the Earth, very similar. Earth's tilted at 23.5 degrees to the ecliptic, Mars at about 25, and they have similar rotation periods. The Earth rotates in a little less than 24 hours, Mars rotates in a little more than 24 hours. That means they have very similar day-night cycles and very similar seasons. And the rovers have to keep warm during the night, because the difference between day and night temperatures can be rather extreme. Day temperatures can be above freezing, possibly even as high as 10 or 20 Celsius, but the night temperatures can plummet to minus 100 Celsius or below. If we think of the Earth has an atmosphere, a relatively thick atmosphere, some 100 times the density of the Martian atmosphere. And so, in effect, the Earth has an insulating blanket around it. So even though the temperature drops at night, it doesn't drop by that much, because the Earth's atmosphere keeps the night part of the Earth relatively warm before, some 12 hours later, the Earth starts to warm it back up again. But without that thick atmosphere, Martian night temperatures can plummet as soon as the sun is below the horizon. And so it's rather important that those solar panels keep the batteries charged, because during the Martian night, the rovers need the batteries to run heaters to keep them warm. If a rover freezes, it basically dies. And the last transmission we had from Opportunity was in 2018, some 14 years after it landed in 2004. So 14 years into its mission, it finally succumbed to the fact that its solar panels were so covered in dust that it found it difficult to get the efficiency needed to charge its batteries. And one day there was a solar storm that kicked up so much dust into the Martian atmosphere, it effectively blocked out the sun completely. And therefore it couldn't charge its batteries, and therefore it went into the Martian night, not being able to keep warm. And its last transmission in June of 2018 was effectively battery low, getting dark. And that was the last we heard from Opportunity. NASA decided after Spirit and Opportunity they wanted to have larger rovers, so greater mass with more scientific equipment, but then you have the problem of how do you power these large rovers. They decided that Curiosity and Perseverance, and I'm going to talk about Perseverance because it's very similar to the Curiosity rover, they decided that they would get there in a very similar way, but they would have to land a little bit differently, and they would have to power it differently. They decided instead of using solar panels, these new rovers would be powered with thermoelectric generators, and these would not be subject to solar panels getting covered in dust. So let's see how Perseverance actually got there. To start with, very similar to Spirit and Opportunity. As you approach Mars, you use aerobraking through the atmosphere to slow you down. There's Perseverance inside its shell, getting rattled about a bit. There's some ability to steer the aero shell so you can go in the right direction. And again, a supersonic parachute slows it down to the point where it can then think about how it's going to land. But this is much more massive than much more massive than Spirit and Opportunity. So it is dropped from its shell, and then it goes into this retro mode of rockets firing to allow it to steer over the surface. But you can't touch down with this because it would kick up so much dust. These retro rockets would kick up so much dust, Perseverance would get covered even before its mission started. So the idea is you decide where you're going to go, and then you go into a hover and you winch Perseverance down on cables. Once it's down, you cut the cables and the sky crane flies away and crashes a safe distance away from Perseverance. Notice no solar panels. The thermoelectric generator is there at the back end of Perseverance. And this particular long, slow pullback of this animation reminds you that even if you've got half a dozen rovers in the past or in the present exploring the surface of Mars, well, rovers don't go that far. They only travel kilometers, not hundreds of kilometers during their lifetime. And Mars is smaller than the Earth, but that's still a huge surface area that you've got to cover. And hence the decision as to where you're going to land these rovers is rather important. So there's Perseverance, or Percy to his friends, and the little helicopter Ingenuity, otherwise known as Ginny. So here we see Percy keeping an eye on Ginny like a nervous adult trying to make sure that the toddler hasn't yet run away. How do you take a selfie like this? Because it looks like there's the camera on top of a mast. So what camera has taken this image? Well, it's another set of camera imagery on the end of the robot arm that is used for taking samples or drilling into rocks. This is how the selfie is taken, not a single snapshot, but a whole series of snapshots that are taken and then mosaicked together to give you the final result. There's the robot arm camera. Circled is the lens. You can see the lens is kept in the same position regardless of where the camera is actually positioned to get all of those snapshots that ultimately get stitched together to make the selfie. So there's Percy and there's Ingenuity sitting next to it, but where did Ingenuity come from? If you want to take a helicopter with you, where do they store it? Well, it's stored on the underbelly of Percy. A plate was removed to expose the helicopter, which then was deployed underneath the belly of Percy. Once the helicopter had its legs out and could be placed on the surface, then Percy trundled away to allow the Ingenuity helicopter to fly. And here's Ingenuity in the bottom left-hand corner. And I hope this comes across okay, but if you listen very carefully, as well as a little bit of wind noise, you can possibly also hear the hum of Ingenuity's blades spinning. So you're listening to a spacecraft flying on another planet. The idea of a helicopter is this particular helicopter was a relatively small one, just as a proof of principle. Is it possible to fly on another planet, even in a thin atmosphere? And the answer is yes. So it's possible that future missions might employ helicopters to do scouting missions and fly over the next hill to double check what's the best way of getting from A to B. Is it best to go round the right-hand side or the left-hand side of this obstruction, for instance? Also, it paves the way for helicopters in other worlds. And at the moment, there are plans to have a Dragonfly helicopter sent to Titan, the large moon of Saturn. The moon has got a fairly thick atmosphere, so it's possible to send a much heavier helicopter and much more scientific equipment. And so we think that Titan will be a very interesting world to explore. And if we can do that by helicopter, then it will be possible to explore a much greater area than would be possible just by landing a lander or a rover and exploring a limited number of kilometers. NASA is always keen to get people on board in the sense of engaged with the whole idea of these missions, which is why it offers boarding passes for anybody that's interested. So, for instance, for the 2020 mission, which ultimately became named Perseverance, the 2020 mission, they gave out boarding passes. There's my boarding pass. And all of the boarding passes from everybody who wanted one were then placed on this particular location. And this white bracket there is the bracket at the back end of Perseverance. So in other words, lots of people have their names on the Perseverance rover, including me. So that means when it goes trundling over the surface of Mars, in some sense I feel like I'm going with it. It gets me engaged with the whole process of exploration. And it costs NASA essentially nothing, because all they've done is add a few milligrams of adding everybody's name to this electronic list that's then put onto the back end of Perseverance. It adds almost nothing to the mass of the mission, but it gets lots of people on board with the idea of exploring Mars. So why do we explore Mars? Well, partly because we want to understand better its geology and its climate. Perhaps geology isn't actually the right word, because geo means earth, but you know what I mean. Study the rocks and try and understand how the climate has changed. It is possible that Mars' change of climate in the past might be something that we can look forward to on Earth. And I say look forward to in the sarcastic sense, because it might be that Mars lost its magnetic field and as a result lost its protection from radiation, and as a consequence lost its atmosphere. We know that ultimately the Earth is going to lose its magnetic field, so maybe the same fate will befall the Earth a long time in our future, but maybe in a sense Mars is telling us what that is going to be like. But one of the big drivers to explore Mars is to ask, does life exist? It doesn't look like we can see life on the surface. That doesn't mean it's there. And even if it's not there, it doesn't mean it never has been on Mars. We know liquid water has existed on Mars, and we know that liquid water is a great place for life to start. We believe that life started in the Earth's oceans. So it is possible that if liquid water existed on Mars, then life did start on Mars. And it is even possible that the water is still there, and who knows, there might even be life in that water under the surface. Some people will say we're exploring Mars to prepare for human exploration. That's a really big step to go from sending robots on Mars to sending people to Mars. It's a 2-year mission if you want a round trip, and keeping people alive for that length of time and protecting them from radiation, as well as making sure they've got all the food and water they need, that is a big problem. One of the current thinking behind taking samples on Mars is there's an indication of what Perseverance is currently doing. It's collecting rock samples and atmosphere samples. Some of them it's keeping on board, and some of them it's leaving on the surface, making a note of where they are so that they can be picked up later. So the question is, how do you get these samples back to Earth? Why do you want them to bring them back to Earth? Simply because the scientific equipment on board Perseverance or Curiosity, it's very sophisticated, but not as sophisticated as all of the analytic techniques that we have available back here on Earth. So if we can collect these samples and bring them back to our laboratories, we'll learn even more about the geology and the climate of Mars. So what is the current thinking behind getting these samples back to Earth? Well, the European Space Agency and NASA have planned this sample return mission. There's Perseverance watching a new lander coming. Perseverance will go and greet it because the lander isn't mobile. Perseverance will then take its samples, of which there might be a couple of dozen or so, and it will transfer them one by one into a container on this lander. What's going to happen to the samples once they're all transferred from Perseverance to the lander? Well, the lander has a little secret inside. It has a little rocket which will allow those samples to go back into Mars orbit. There's Perseverance watching them fly away. The samples will go back to Mars orbit, where they'll rendezvous with an orbiter, and then the samples will be sent back to Earth. This is the plan for the Mars sample return, a joint mission between NASA and ESA, the European Space Agency. Unfortunately, fairly recently, a certain president has decided to cancel the funding of this Mars sample return. ESA can't really afford to do this on their own, so at the moment it's not altogether clear how we are going to get these samples back. They are being collected and will continue to be collected by Perseverance, and hopefully it won't be too long before we figure out how this particular mission is going to take place. But what about the next steps? Well, the next rover on the surface of Mars will be an ESA rover. Up till now, they've been Chinese or American, but we are going to have a European presence on Mars, hopefully in 2028. The Rosalind Franklin rover. As you can see, it's a relatively small rover. Solar panels are cheaper than having thermoelectric generators. It's a relatively small rover with a relatively limited lifetime, but what makes this rover different from all the rovers that have been there so far is this black box on the front that you can see there. It's a drill, and that will allow it to drill down to about 2 meters, and it's thought that if surface water doesn't exist but the water is below the surface, it is thought that the water might be less than 2 meters below the surface. And so Rosalind Franklin is going to land and drill down to actually see whether that subsurface water does exist. If it's there, that will be a bit of a game changer. We know water has existed, we know water has flowed on Mars, we know there have been rivers and lakes. If the water is still there below the surface, that gives us a whole new area to explore. So the ESA rover is being built. It's currently being put together by Airbus UK. So yeah, the Union flag will one day fly on the surface of Mars. Here's it being put together in Airbus. I think the engineers need to be told that the wheel at the back seems to have been replaced with a shopping bag, and they've only got 5 wheels there, not 6. I think they know that, but we'll give them a wave anyway because they're doing a great job, and hopefully this will be ready for 2028. If I've piqued your interest in terms of the rovers that currently exist on Mars, or those that have been on Mars, or those that will be on Mars, you can find more information about robots on Mars by looking at the national space agencies of America and the European Union and China at these locations here. Thank you very much.